Hello everyone, this is Wilson. Welcome back to my 1 minute presentation. Today, I'm going to give a very simple calculation example on the fire spread rate or fire spread speed based on the previous free presentation, which is about the fire spread. So let's get started. So here is the example. So what we are going to do is to calculate the outward fire speed of a very thin paper. So the thickness of the paper is just a 3 micrometer, and the fire spread is spreading from the bottom to the top. So we will have a flame height which is around 0.1 meter, and the fire spread speed direction should be upward. And also, as we are having a fire in the paper, so the temperature differences between the fire and the air will cause a buoyancy velocity. So I will discuss these things in the next slide. So we try to calculate the fire spread speed first. So the paper usually is made out of wood. So I would say, let's assume the density of the paper is 800 kilogram per meter cube. So sorry, this is a meter cube. Sorry. So the density of the paper, let's assume it as 800 kg per meter cube, and the heat capacity of the paper is around 1,400 joule per kilogram per Kelvin. And the fire heat flux, let's say 20 kilowatt per meter square. So let's write the equation again. So the velocity of a flame fire spread velocity for the thin field should be equals to the fire heat flux times the flame height divided by the density, thickness, heat capacity, and the temperature differences. So this is the ignition temperature and minus the ambient temperature. So let's substitute all the things into the equation, and we will have a 20 kilowatt per meter square heat flux, 0.1 meter flame height, and 800 kilogram per meter cube density, 3 times 10 to the power minus 6 thickness, and 1,400 joule per kilogram per Kelvin heat capacity. So the ignition temperature of anything is equals to the pyrolysis temperature. So the pyrolysis temperature usually is around 300 to 350. So let's say it's 330 in this situation, and minus the ambient temperature, let's say 30 degrees Celsius. So after calculating this formula, we will get the fire spread speed of this situation is equals to 2 meter per second. So this is how you calculate the velocity. So I've extended this question for more, so we will have 2 more questions. So the first question is that, so in this situation, whether this situation is a forward spread or a opposed fire spread. So as we can see, the flame velocity or the fire spread velocity and the buoyancy velocity will have a same direction. So in the previous diagram, we can see that they are having the same direction. However, they are not the forward fire spread. So why? So as we calculated in the previous slides, the fire spread velocity is equals to 2 meter per second. However, the calculated buoyancy velocity is nearly equals to 1 meter per second. So the buoyancy velocity could be calculated by a square root of gravity times the gravity times 1 should be Let me check it. So, oh, sorry. So the buoyancy velocity can be calculated by the square root of gravity times the flame height. So we will have a 1 meter per second. So let's imagine you are running. So your running speed is just like a fire spread speed. So maybe you are running at a 2 meter per second speed, and then we will have a wind will have the same direction of your running direction, and the wind will have a 1 meter per second. As you are running faster than the wind, so you can feel that the wind is doing something to you. So you may feel that the wind is hitting your face. So the wind is slowing you down. So I would say it is a opposite fire spread. So another question is that, how about just turn the paper from the vertical spread to a horizontal spread, just like that. So in our previous question, we will have a vertical spread. So how about we just turn our paper 90 degrees to a horizontal spread? So the calculation equation should be the same, but the answer is not the same. So why? So the flame height in these two situations is different. So in the vertical spread, they will have a higher fire height, but in the horizontal spread, it will have a shorter fire flame height, so that after calculated, we can find out that the horizontal one will have a lower fire spread speed. So this is the end of my presentation. Thank you.